Hi there. Now in the first part of this question we were given that the positive constant a and so on, okay, so we don't need the rest of the original question, but just to know that a was a positive constant. Well, for this part we're asked to show that a equals 1 is a root of this equation here, 3a cubed minus 5a squared plus 2 equals 0, and hence find the other possible value of a. Given your answer in simplified surd form. So if you'd like to have a go at this and haven't done so already, just give you a moment to pause the video. Okay, welcome back then if you had a go. Now to do this, what I'm going to do is let f of a be the expression on the left hand side of this equation. F of a, in other words, equaling 3a cubed minus 5a squared plus the 2. Now what I'm hoping is that if a equals 1 is a root, then when I put it through here we should find that it equals 0. So let's just put that through. I'll say then f of 1 will equal 3 times 1 cubed. First of all, 1 cubed is 1, 3 times 1 is 3. Then we've got minus 5 times 1 squared. Well, 1 squared is 1, times it by 5, you got 5, and then plus 2. And what does this come to? Well, 3 minus 5 is minus 2, add 2, that's 0, so that's good. So, therefore, a must equal 1. A equals 1 is a root, okay? So that answers that first part. And then it says, hence find the other possible value of a, given your answer in simplified surd form. Well, we'll talk about this simplified surd form at the end. Now, if we're to find this other possible value of a, then I need to factorize this equation so that I can solve it. And there's several ways that I can do this. I can either do it by long division, algebraic long division, to find the quadratic factor, or I can just do it by inspection. I'll show you both methods. I'll first of all do it by inspection because it's very quick. So if we have our equation now, 3a cubed minus 5a squared plus 2 equals 0, then we know that since a equals 1 is a root, then this would have factorized having a minus 1 as a factor. Then there would have been a quadratic factor in here, and this would have equaled 0. So if I'm going to guess what this quadratic factor is, it's got to be 3a squared at the start, so that a times 3a squared gives me 3a cubed. And as for the constant plus 2 at the end, I've got minus 1 times something has got to give me that constant. So that's going to have to be minus 2. Now, as for the term, say, in a that goes here, we want something that, say, is going to multiply out with this a here and give us the minus 5a squared. Well, if I multiply, say, the minus 1 with the 3a squared, that would give me minus 3a squared. So to get minus 5a squared, I need another minus 2a squared. And that would come from a times minus 2a in here. So I hope that makes sense, all right? If you check that out, it will give you that a squared term. A times the minus 2a gives me minus 2a squared, and I get another a squared term when I do minus 1 then times 3a squared. That's minus 3a squared. Minus 2a squared minus 3a squared gives me the minus 5a squared. Well, I did say that you could get that factor just by doing algebraic long division. In fact, I'll do that at the end so you can see how it works. But for now, we've got our quadratic factor and we should be able to solve this. We can see that this factor would have to equal 0, so we'll put therefore a minus 1 could equal 0, and this would result in a equaling 1. Well, we know that because we've seen it up here. It's the other one that we're interested in, this quadratic factor. when that equals 0. So I've written or 3a squared minus 2a minus 2 must equal 0. Now if this is the case, then being a quadratic equation, I'd normally want to factorize it to solve it. But it does say give your answer in simplified third form. And this is suggesting that it's not going to factorize, that we need to use the quadratic formula. Or you could do completing the square. But the quadratic formula would be a lot easier in my opinion. So let's just put this down, that when 3a squared minus 2a minus 2 equals 0. What we've got, remember, is that a in this case would equal minus b plus or minus the square root of b squared minus 4ac all over 2a. But the a coefficient is 3, b would be minus 2 and c would be minus 2. Okay, I know it seems a bit strange when normally this is an x in most quadratic equations. So a equals minus b, so that's going to be minus minus 2, so that's 2, plus or minus the square root of b squared, so that is minus 2 all squared. Okay, make sure you have that in brackets. Minus 4 times a being the 3 here, times c being the minus 2. And this is all divided by 2a. The a, remember, being the 3 there. So it's 2 times 3, in other words, 6. So if you clean this up, okay, what have we got? We've got 2 plus or minus. Inside the root, we got 4. And we've got minus 12 times minus 2, so that's plus 24. 24 plus 4 is going to be 28. So we've got the root of 28. And this is all divided by 6. Now the root of 28 can be broken down. This is exactly the same as 4 times 7. So we've got 2 plus or minus the root of 4 times 7. And that's all over 6. If I apply the multiplication rule for surds here, that's exactly the same as the square root of 4 multiplied by the square root of 7. Square root of 4 is 2, but we'll leave root 7 as root 7. And that's divided by 6. So what we've got here is I can see that I could divide each of these terms, top and bottom, by 2. So that's going to be 1 there, plus or minus root 7, all divided by 3. Now, we're told that a is a positive constant, so we can't have these two answers. One of them is going to be negative, and that would be the 1 minus root 7 option. So if we just come down here, okay, we can finish this off. We can see that if I just say, but a has got to be greater than 0. It's a positive constant, so therefore a must be the positive option here. It must be 1 plus root 7 divided by 3. Okay? Now I did say that there was another way that we could get this quadratic factor, and that was through algebraic long division. And so what I'll do is I'll just do it in this space here, okay? And that is, we could divide a minus 1, okay, into the cubic equation here, 3a cubed minus 5a squared plus 2. When we write this down though, you've got to be careful because it hasn't got an a term, so we fill that out with a 0, 0a, and then plus 2. Now I'm assuming you're familiar with algebraic long division. If not, you can always check it out on my website. Now what we do though is we say, what do we multiply a by to give 3a cubed, and that would be 3a squared. So you put that there, multiply 3a squared with a minus 1. So 3a squared times a is 3a cubed, put it underneath here, and 3a squared times minus 1 is minus 3a squared. And what we do next is we subtract these two from one another to get the remainder. 3a cubed minus 3a cubed is 0, and then we've got minus 5a squared minus minus 3a squared, which is going to be minus 2a squared. We then bring down the next term, which in this case is 0a, no a's, okay? And we start all over again. What do you multiply a by to give minus 2a squared? Well, that has to be minus 2a. So put that up there. And now we do minus 2a times a minus 1, which will give us minus 2a squared. And minus 2a times minus 1 is plus 2a. Subtract again to work out the remainder. And we find minus 2a squared minus minus 2a squared is 0. 0a minus plus 2a, well, that's going to be minus 2a. Bring down the next term, the plus 2. So you can see this is quite long by comparison to what we did over here just by inspection. But still, we're getting our quadratic factor. So again, what do we multiply a minus 1 by to get minus 2a? Well, it has to be minus 2. Minus 2 times the a now is minus 2a. Minus 2 times the minus 1 is plus 2. And we subtract again to work out what our remainder is. And we find the remainder is 0. So there's our quadratic factor. And we would carry on then just as we did here. Okay, well, I hope that's been of help if that particular problem caused you any problems. All right.